Next problem. Following are the risk and return of two stocks. The information is given about the stock's expected return and risk. So expected return for X, expected return for X and Y, and expected risk for X and Y are given. So expected return for X is 5% and expected return for Y is 15%. Same way risk is 20% and for Y it is 40%. The following proportion of investment is made on X and Y respectively. So stocks and proportions are given. So on the stock X, the proportion is 2/3 and on stock Y it is 1/3. So if you take it in decimal way, then it is 0.67 and it is 0.33. 2/3 and 1/3. It is given in fractions. So for easy of doing the calculations easily, we have to take it in fractions, decimals, or else you can do it in fractions also, no problem. So assuming coefficient correlation of R is equals to +1, R is equals to 0 and R is equals to -1, calculate the risk of portfolio separately. So you have to find out the return as well as the risk in three cases when coefficient of correlation R is equals to +1, R is equals to 0 and R is equals to -1. We'll see one by one how to do it. So for calculating the portfolio return, we know that it is summation return into individual returns into weights. So that is R bar X into X plus R bar Y into XY for X stock and Y stock. So what is return on X is 5 into 0.67. The proportion we are taking here, that is weights. It is 0.67 and 0.33, 2/3 and 1/3. That comes to 8.3%. So then coming to the calculation of portfolio risk, it is denoted by standard deviation. So sigma p is equals to the formula, you put it the formula here by squaring the values, by squaring the values or values of both the scripts and then giving the relationship, that is covariance of the two different scripts or stocks. So the first case here, when R is equals to +1, you have to take three cases here. That is when R is equals to +1, when it is 0 and it is -1. So when R is equals to +1, take the values here, substitute X is 0.67 the whole square into standard deviation or risk is 20 the whole square plus 0.33 the whole square into 40 the whole square plus 2 into 0.67 into 0.33 for X and Y, whatever proportions are there same. Then standard deviation, the values of risk values. Then R is 1. So in that case, just when R is equals to 1, substitute the value as 1. R for both the scripts is into 1. So in this case, you are going to get the value as 26.6%. Next case we'll see when R is equals to 0. So second case, when R is equals to 0, what you have to do, the same thing, you have to substitute the values. Then wherever R value is there you have to put it as 0. You have to put here as a 0, this value. This R value we have, no? So this value will be 0. So wherever I have pointed that R is equals to 0, there you have to put it as 0. This particular value, R value should be 0. So when you do the whole calculation, then you are going to get the values. You do it separately. I have just given the value here instead of doing the calculations. So you have to square it up, and then you have to write the value here, whatever value you are going to get. That is 18.809 percentage. Then third case where R is equals to -1. In that case, same again, you have to take the same values, substitute the values in the formula, and then at the end, wherever you are going to get uh, R value should be -1. So this value will be -1. Substitute that value and then do the calculation. So you are going to get the answer as 0.2%. So this is how you are going to calculate return as well as risk in Markowitz model when there are two securities.